Hello guys, today we're going to do a bit more work on the John Deere 8360 RT model, and I'm just going to try and add the electronics into the bottom half of the model here. We need to add a few LEDs to the back of our tractor, and I want to change out this motor. That's the first thing I'm going to do. I'm going to use one of the motors from the N20 gearbox motor test. Maybe one of the kind of mid-range motors, because this one is obviously way too slow. So first thing we're going to do is find a motor that works well for that, then add the LEDs, and hopefully if we have time we'll get the Arduino installed and the motor drivers installed, and we'll go from there. So first thing to do, switch out this motor with one of the new motors and see how fast the lifting arms work then. Okay, so I've changed the motor out with a faster motor here. So I'll just show you the motor lowering the mower there. So it's the right bit faster. I think this is probably a good speed to have. And remember, we've no proportional control, so it doesn't know when the motor is fully up or when the motor is fully down. So we don't want it too fast or we just end up damaging it. This is just a first attempt at this, so I think we'll go ahead with this design and see how it works. I got an order last week from IC Station. I have a few Tower Pro servos. This is a micro servo, so we might check it out, see how it's going to work with this design before we close everything up. See if a servo would be a better solution. First thing I had to do to get this servo ready to fit in here was just cut this end piece here of the servo arm, so that it would actually fit into the model without hitting the lower half of the model. Now I should point out that using a servo like this is only possible in this model because it has quite a wide base. This is a lot of space compared to, say, the Fendt 936 model. You'd never fit this servo into the Fendt 936. So although this might be a good solution, it's only really going to work for this one model. Okay, so now I have the servo connected to our lifting arms by the little bar here. You can see it just there. That's connected into our servo in here, and now to test that out I'm going to have to try and hold the servo in place and operate the control, because I'm using an IC Station Mega here and just a little potentiometer. So I showed you how to do that in a tutorial before, or another one of the videos. So if you haven't seen that, if you have a look through the channel there, have a look in the videos, you should be able to see a servo tester circuit. So that's all we're doing here. I'm just using a Mega this time instead of an Uno. Okay, so I have the tractor over the edge of the table here, and I have a hold of the servo inside the tractor. So if I turn the potentiometer, you can see there's the movement that we have. Now the difference between this and the screw mechanism is that we're always going to be wasting power when we're trying to lift a heavy load with the servo. Like, you can hear the servo is buzzing there. Well, I can hear it. I don't know if you can hear it on the screen, but that means we're wasting power because we're trying to lift that. So we don't seem to have any trouble lifting it. So that's a good sign. And using the servo will be a lot simpler to control. We only have to just connect these 3 wires to the Arduino, whereas with the screw mechanism we would have to add another motor driver. So for the sake of simplicity, I think I'll just mount this servo inside the tractor. It's probably not the most efficient way to do it, but it is pretty simple. It'll leave our wiring a bit simpler, and it seems to be working okay with that load. So let's do that. We'll mount the servo inside the tractor instead of a screw mechanism. So to let the servo operate properly, I had to grind away this part of it's kind of well, it used to be a screw that held on a plastic part of the body, but I'm not using it anymore. I'm just relying on these two screws to hold on the body, and it's not under any pressure anyway, so it shouldn't matter. I also needed to cut this part away to let the wire go through. Then I drilled 2 holes here to 3mm, 2 holes here to 2.5mm, and I tapped these 2 holes. And I have a couple of pins that I can put in here to connect our servo in. So we have our 2 pins here. So let's get our servo, and we can hold the wire back here, push it down there, put the pin in one side, over, and just thread it in the far side. I can get it. So thread that in there. Get our wire. Little tug on the wire just to keep it tight while we get the pin in past. And through the servo over to the other side. And we can thread that in over there as well. So just finger tight should do. It's not going to be under any real pressure. So there we go. And there we go. And that is our servo mounted in here. So now I just need to bend this little bar to the right size, and we can pretty much put it back together then. Okay, so here's our servo installed. I had to add this little strengthening bar to stop the servo from moving, and our little bar connected over there is the right length now. So test it out here. That works absolutely fine. So I've added a little bit of weight here, so let's test our servo there. It's not too bad, it seems to work okay. Seems to have more than enough power for that. Okay, so that's everything I have for this week. If you liked that video, give it a thumbs up or hit the like button. And there'll be many more videos in this series. The next one is going to be adding LEDs to the rear of the tractor. So if you want to see that, make sure and hit the subscribe button. That's everything, so thanks very much for watching.